Hi. I'm gonna become the third green brother for a hot second and give you the crash course on the basics of immunology. Whoa, this thing's moving around like crazy. Big picture, we're looking at like two wings of the army that is our immune system. You've got the innate immune system and the adaptive immune system. The big difference between these two wings is that the innate immune system works by recognizing patterns that occur commonly on pathogens or damaged cells, whereas the adaptive immune system recognizes specific antigens or targets on the pathogens or cells themselves. One layer deeper, we see that the adaptive immune system has two big players, I guess, B cells and T cells. B cells are the workhorses. They churn out like a little protein you've probably heard about. It's called an antitokounmpo. I'm just playing with you. I'm messing with your bud. They're called antibodies, aka immunoglobulin. Antibodies are like super important for our immunity, like primarily because they can like act as like red flags attaching to pathogens for other innate immune cells to eat up, like phagocytize, say a macrophage eating up like a bacterium with an antibody tag. Or they can like make the pathogen immobile by clumping them up together via a process known as opsonization. And like they can also straight up just neutralize the pathogens too, which is super cool. And then we got our T cells, which I don't know, it's my apple of my eye, which kill like bad cells, like cancer cells or cells that harbor viruses. And you may say, how do we know if the cells are bad, you might say? There's this special receptor that's basically Spotify wrapped for your cells, and it's on every cell except for red blood cells, who apparently use Apple Music, I think. But anyways, this receptor is called the MHC, and it takes proteins from inside the cells and retrieves a small snippet of that protein to present on the surface of the cell. If there are any non-self proteins inside the corrupted cell, T cells should be able to bind with the MHC receptor with strong affinity and then kill off the bad cell, whether it be like Trojan horse for a pathogen like a virus or a cancer cell. TCRs and MHCs and HLAs, like they deserve like a whole... they deserve to be focused on somewhere else because like they're too complicated and like to be shoved in like as a side note with the rest of this stuff. I'm gonna give you the love and care and respect you deserve. I'm not gonna go to the store for milk. I swear. Immunological memory is one dandy thing. Certain cells like B and T cells have the capability to remember the antigens and pathogens as a result that they encounter. Let's say you go to a Justin Bieber concert for some reason and you unknowingly catch the Justinia virus, which makes you get Bieber fever. Real dangerous stuff. Be careful out there. When you first encounter the Justinia virus, your immune cells don't know what it is. But because of this one method called TCR or BCR recombination, by which our adaptive immune cells make receptors for every possible non-self antigen, you're technically already able of fighting the Justinia virus. The problem is, though, this whole process of getting B and T cells to activate takes a few days to get started, like in full force, by which point Justinia virus has already grown exponentially and started to create damage in our body. So that's why memory exists. After the initial encounter with Justinia virus and recovery from Bieber fever, memory B and T cells specific for Justinia virus are created, which last long periods of time throughout the body, not just in the lymphatic system. These guys are lightning quick and activate much faster than your initial naive T and B cell reactivation, which is super important for keeping infection at bay. Cells specific for different pathogens or targets convey memory through a process of cloning themselves over long periods of time. The focus of this video is on memory T cell subtypes. Immunologists like putting everything into categories, so based on differing functions and phenotypes, they've created a system by which they classify memory T cells, which obviously protect us against the second wave of Justinia virus, or the second encounter with the Justinia virus, or any virus in general. The whole exercise of classifying memory T cells into subtypes really started with this one paper from 1999 that distinguished two subtypes of the memory T cell by where they home. The two subtypes that they identified at the time were that of the effector memory T cell and the central memory T cell. The effector memory T cell, abbreviated as the TEM, predominantly lives in the blood and in the circulation, and if it's feeling adventurous on any particular day, it can also be spotted in the periphery. The cell does not express the markers CD62L and CCR7, which are really important for lymphoming, and in my honest opinion, I think they're kind of garbo in comparison to the rest of the subtypes in the list, just like because of the fact that they have shorter memory, they're more differentiated, and they have less of a capability of producing an important cytokine for T cell cloning called IL-2. But hey, I mean, honestly, they get the job done, they go fast and hard, with somewhat quick reactivation speeds, a great possession and capability of producing perforin, which is important for murder, cytotoxic murder, of course. I mean, I'm not talking about humans. I mean, we're made of cells, though, so take that as you will. In that same paper, the other subtype that was defined was the central memory T cell, often abbreviated as the TCM. The central memory T cell expressed CD62L and CCR7, and because of that, they live and breathe lymph. These cells convey memory for a considerably longer amount of time than effector memory T cell, and they seem to also have robuster responses. But yeah, they're like TEM, but better because they live in the lymph and they do a lot of the functions in a more full manner. Stem memory T cells, abbreviated as TSCM. This one's kind of weird. I don't like the abbreviations, messed up. But they are like central memory like cells' bigger sibling. They have all the traits of the TCM, central memory T cell, but amplified, beefed up. They live an incredibly long amount of time, with reports of them living and perpetuating memory for greater than 25 years after yellow fever vaccination. Wild. These cells are CD45RO negative and CD45RA positive, whereas other memory T cells would be the opposite, so reversed. They've been noted to have an increased proliferative capacity in comparison to all of the other subtypes, and just seem to be awesome at what they do in terms of being at the peak of the circulating memory T cell subset category. Yeah. Finally, we have the resident memory T cell, of course, aka the TRM. I had shakshuka for the first time yesterday. Super good, a very good chef's kiss. And TRM, I'd vouch, are the shakshuka of the immune system. They convey tissue-specific immunity, laying there, just like the eggs laying in the tomato sauce, except our tomato sauce is full of hemoglobin and blood and all that gnarly stuff. There are TRM in the lungs, the skin, the brain, any tissue really, just name it. And you can typically identify these guys via CD69 and CD103. These guys are on the come up right now, and tissue-specific immunity could be really important in the near future, whether it be against pulmonary viruses or any other pathogen and disease localized to specific tissues. Unlike all of the other subtypes, obviously, these guys don't circulate that much. These lazy fellas instead just monitor their immediate surroundings and tissue, which can be really useful for really any disease. They activate quicker and more diversely than all of the other subtypes, and honestly, are some real champs who haven't gotten their well-deserved flowers just as yet. But I love you, TRM. I love you. A lot of these cells can change phenotype, however, so it's not super linear, and a stem memory T cell doesn't necessarily have to stay a stem memory T cell for its entire life. It could change into a TRM, a TCM, or a TEM, given the right signals, of course. Many of the other subtypes can differentiate into each other too, so there's a lot of leniency when it comes to memory T cell phenotype. But yeah, that's been it. Stay tuned. Yeah.